do we ever like use this like find like actually
That's all right.
No, I got it.
Okay.
Say if I want to put money in right now and just put it in a bank, how much compare?
So you get 5%.
Can you like compare it like
Yes.
if I put money in right now?
We'll do some examples of that.
Okay.
Okay. I'm not sure we'll get to it today at this point. John, I'm going to ask for one more of these here. I'm going to take my dollar, and I want it compounded 10,000 times yearly. I want you to figure out, that's roughly 30 times a day. I want you to figure out my interest rate. So that's going to take my dollar.
That's what?
10,000 times a year. So that's like about 30 times a day. I want you to take out my money, figure 1/10,000th of the interest rate.
So would you multiply 30 by 1 over 10,000?
Okay, hold on.
No, here's what I would do. All I would do is plug 10,000 in for n into my compound interest formula over there. So that's going to be 1, which is my principal, times 1 plus my rate, which is still 100%.
So it'd be 1 over.
1 over 10,000. And then that'd be raised to the 10,000th power. What is that, Johnny?
It's it's rounded to 2.72.
Can you give me out a few decibels?
Right,
2.718145927.
59.
I will stop there. Excellent.
What did you get?
2.71814.
So
I got something wrong. I got something different.
Isn't it?
Oh, no, I didn't.
Ooh, Stephen is thinking of something. Stephen is having a thought. He's having a little epiphany.
It gets taller.
a little bit.
You can't cross that line.
Yeah.
It becomes an asymptote.
Is that how much would make?
It's E.
What? Oh.
We're getting close
Screw
to E.
you, Andrew Jackson.
Wait.
Screw you.
Okay, guys.
No, it's off.
It is off. It's not quite E. But, Stephen, if I keep raising this compound number, it will keep getting closer and closer to E. And as James just pointed out, it will actually approach E like an asymptote and never cross it. This is actually why E is, it's why E is E. This is why E is the number that it is. What E allows you to do is E is a number that shows up anytime you have something that's changing in proportion to how much of it you have. If you have more money in the bank, you get more interest, right?
In the bank.
Okay, correct?
Right.
You get more interest at any given moment. This is one of the early ways to figure out E. Leads, keep taking this dollar at 100% interest, keep compounding it more and more often. Also, this means, hang on, there's a limit to how effective compound interest is in getting you a return on your investment, okay?
It's pretty low.
You would think that if you kept compounding it over and over again, your return would keep going up. But it doesn't. There's a limit on it.
1
You're
cent
driving it into smaller fractions.
Between the two.
Yeah. So $1 at 100% interest, compounded as much as you want, you will never get more than $2.72-ish cents back. No matter how often. You compound it an infinite number of times. And in fact, that...
E is 2.72.
No, 2.71828. But it rounds to 2.72.
Goes on for
Because 1814 was Massachusetts, not Andrew Jackson.
Excellent.
God.
Okay, now, there's the Treaty of Ghent, right?
Yeah.
Yes.
The year in which Andrew Jackson won the decisive battle, which led to his popularity, which led to his
Battle of
election.
New Orleans.
Yes, thank you. Okay, now.
2 weeks after the Treaty of Ghent was signed.
Right. Okay, now.
APUS.
All right, guys. Hey. Hey.
Alright.
Stay with us.
You
Now.
started it.
Shh. Okay, I did. But now, let's come back here. Okay. This is why, and I'm not going to do the direct derivation, but this is why if you have...
So E just basically means you are compounding it an infinite amount of times.
Kinda. And that's why if we say interest compounded continuously is the term, which means every possible second of the day that you can imagine the interest being compounded. It's as if like there was some magical way to take your money out every instant of the day, every infinitely small moment. Look at it, apply an infinitely small interest rate, and put it back. It looks, the formula for that is the amount of money you'll have in the bank will be the principal times E raised to the rate times time. I haven't proven that to be true, but I've given you a little hint on why it is.
You haven't or no one has?
Oh, plenty of people have. I'm just not doing the formal proof right now. And honestly, I didn't prep it and couldn't do it off the top of my head. I'd have to double check it somewhere. But this gives you a hint how important E is and where it pops up. This was one of the first exercises used to derive E, actually. About 1,000 years ago, when people started figuring out there was this crazy number that kept showing up if you tried to figure out population growth.
Why E? Why part?
You know, why pi? Why the square root of 2 is a diagonal of a square?
I don't know. I was
It's just...
wondering if E had some interesting story.
This is a story on its derivation. There do seem to be certain numbers that nature, the good Lord, the force behind the universe, science, whatever you want to call it, seems to like more than others. And they all do seem to be irrational numbers that go on forever. So
Isn't that just how we made math, though? Because we kind of came up with it.
there are many things in math that are absolutely man-made.
What do you come up with?
Okay, there are many things in math that are like scientific notation. That is totally a product of base 10 and our preferences. The fact that the independent variable is always horizontal, that's just a man-made preference. Some of this stuff really seems to be more of a discovery than an invention. And irrational numbers really seem to be something we've discovered more than something we've invented. No one would have invented them, and there were efforts for about 4,000 years by mathematicians to explain them away, to try and see if we could come up with a system of math that did not include pi. There was even a fantastic effort by, I believe it was the Illinois State Legislature in the 1800s, to change the value of pi. They thought pi was too weird an idea, so they just wanted to make it 3, like by law.
What?
Like they would make it by law that the ratio of this diameter and this circle would be 3.
That's stupid.
Yeah.
Which, yes, it is very
We should them.
dumb. But we can't get away from it. This truly seems to be something. E, pi, a couple other numbers really seem to be discoveries, not inventions. A lot of math is invention.
It's actually one of the dumbest things I've ever heard.
The Illinois State Legislature one. If you think politicians are done thinking that way, very quickly, in the state of Maryland, Montgomery County, about 20 years ago, there was someone who did not like the state police motto, which was a Latin. I forget what the Latin phrase was, but it basically literally translated to something like manly deeds, womanly words. And what it basically meant was like, it was an old Latin Roman saying that meant like be strong when you have to, be compassionate when you can. Because men were strong and women were compassionate, very stereotypical.
Oh, that's not sexist at all.
No, but this one legislator did not like the translation, couldn't find the money in the budget to get the motto changed and repainted on all the police cars.
He wanted to change the language.
He wanted to change what the Latin meant. He wanted to come up with a new motto and say that in Montgomery County, the old Latin words would mean this new motto.
Yeah, that's dumb as well.
It was
Yeah.
just change history at that point.
I know, that's absurd.
I get really bothered by dumb
So
stuff.
what did he want to change it to?
I forget, something more macho like Montgomery County Police kick butt or something.
That's the main thing.
But he didn't want to change the Latin.
We know that Abraham Lincoln.
What?
Yeah,
No, they don't have the cars.
What's his name?
It is. Okay, now,
Okay.
I mean, I do now.
next topic, related. Transformations of the graph y equals e to the x. Okay, when you're graphing an exponential graph, when you were graphing, Lauren, an exponential graph, okay, there's always 3 points that I'm very interested in.
Which one?
Okay, I'm always interested in, I like to make a table.
1.
Yeah, 3 points I'm interested in are always when x is -1, when x is 0, and when x is 1. Now, if we're looking at y equals e to the x, what is e to the -1 going to be? Give it to me. Well, tell me this much. What does the exponent tell me to do?
1 over e.
That's actually exactly the answer I was looking for, which is going to be some small fraction. When x is 0, what is anything raised to the 0th power? 1. And when x is 1,
It's e.
it's going to be e. So every basic exponential graph, what I call the parent function, whatever you have before you include shifts and transformations, every basic one always winds up looking something like passing through the point 0, 1, passing through the point 1, in this case e, but 1 whatever the graph is of, and then passing through some point less than 1 over here, looking